Hi all. Good morning.
Good morning, sir.
Good morning. Okay. So we are any query here related to our previous session yesterday? I hope. Okay, now we are predicting with binary. Hmm. 11 people. Okay, we'll wait another 1 minute. Then we'll start. So to give a quick recap, yesterday's session we saw the missing value imputation, right? And categorical and continuous value imputation. Today we are going to see how to impute when treating these missing values as a separate class. Okay, that we'll see.
Hi Ashish, good morning.
Good morning.
And about this group and all, yesterday I've asked, but it's against the rule, they said. So they said like we can't create it.
Is it?
Yeah.
Okay.
Yeah, I just asked my coordinator and then it turned into like another thing, and then and main boot coordinator and all those like started to calling me like guys, don't do it. If it is so like we have to send a warning mail like that. They've like they've I also started to like what happened. I also started to panicking. They are also started to panicking. Like, don't do it like that.
Okay. But how come it is there in some other batches saying from yesterday?
Yeah, they were having it actually, but this is that like without our permission they were having it. If there is any issue, or else if someone comes to know that okay, if for example, if I'm coming and saying to you that like I'm having in group and that guy said this guy said this, then like the guy who was told you right, yeah, about the group or else about the issue, like not only he'll get an warning email, like who all are the participants in that group, they'll get an email
Oh, okay.
like that, they said. Yeah, so warning email is not only for the people who all are like get into a jeopardy, like for the every group, each whole
Oh,
group.
okay. Okay.
So,
Okay.
Dinesh and Ashish, so like, can we create like what do you call a link on Instagram or like on Twitter or even Threads?
That's what Dinesh is saying, right? They are not okay with that.
Yeah, like, and also they've shown some documentations like when we were joined also, like you can't contact with the peoples in social media and all those has been there, Dinesh, like that they've told the
So Dinesh, so like what I suggest is like, can we can create an alumni like thing on Threads or like on any other platform of
Yeah, alumni, that makes sense.
yeah.
But
So from there we can
let's see.
continue.
Okay. Let's
But not
see.
sure.
Let's
Yeah,
continue our journey today. Let's see then.
yeah, yeah.
Sure, Ashish.
Let's get okay. So guys, from where prediction of missing values using a separate model. So here you are going to know about some future topics like model training and all, but in a smaller level, not that much. But yeah, you will get some idea how to how this model is being created, some basic idea. That means, suppose for this example, okay, this is the example, and I got some error. Why this error is occurring? Import pandas pg.
NP was not defined.
Okay. Now suppose this is my data. Just a smaller example to make you understand. So this is my data, and if you can see here, row 2 and row 3, that means index 1 and 2, is having some NaN values. Did you understand how I created this data frame? No doubt, right? Here I'm knowingly I'm creating the NaN values using NumPy library. That means the NaN data type we can create also using NumPy library. Now here, if you see in this data frame, we have A, B, C, D, 4 column and 4 rows, where 2 rows containing NaN values, which is inside B column. Okay. Now what is happening? Let me explain you here. I'll explain the code here in the above cell. First of all, try to understand one thing. Okay, this I think not required here. This one, once you progress with the machine learning algorithm in these courses, you are going to encounter this one, and this is how you are going to create a model. Okay, maybe the algorithm, to understand the algorithm and to understand the mathematics behind it, it will take some time for you. But after you understood, in Python, it is just a one-liner code to create a model like this one. Scikit-learn is a library which contains all the machine learning algorithms in Python. Okay, scikit-learn. And from scikit-learn, we are importing random forest regression. This is a model. Okay, this is an algorithm, random forest algorithm, which is here we are taking the regression algorithm. So there is two types of algorithm you are going to encounter. One is the classification algorithm, one is regression algorithm. What is the difference between classification and regression? Anyone who knows?
Classification is like when we have data which can be classified into some categories, some discrete values, and regression
Correct.
when we have some continuous values.
Suppose that house
There are
price
random
prediction.
values.
House price prediction means you have to create a model which is going to predict the price of the house. Now the price of the house is a continuous value, right? It is not a category. That is a regression problem. Okay. And classification means, suppose that fraudulent, non-fraudulent transaction, right? Here you are classifying your output as two types, either fraudulent or non-fraudulent. So this is called classification problem. So here I am using regression. Why? Because I am going to deal with the continuous value data. And this is how you can create a model. Now, if you see here, I am dropping, okay, let me explain you how this works in machine learning. Suppose this is your machine and I am talking about supervised learning. I hope you now understand what is supervised learning, right? So if this is your model, okay, and this is, so suppose not model, suppose consider this is your data. Okay, this is your data which contains the independent variable and the dependent variable. That's why it is supervised learning. Okay, outcome you know, right? Outcome you know. Now in machine learning, how this works, you consider the independent variables, that means the x values, as you consider x values as your x and this values as your y. What values? That the target values as your y. Now here in machine learning, you have to divide this into two things. What is that? X train and X test. What is X train and what is X test? So what does that mean? That means from your this data, you are going to divide this into two parts. One you are going to use for the training purpose. One is you are going to use for the testing purpose. Now, what does that mean? Suppose I have 100 rows, 80 rows I will try to use for training and 20 rows I will try to use for testing. Now, when training, the model will learn from the training data. That from that 80 number of rows, model is going to learn that. Okay. Now here, what I mean by training, we have X and Y, right? So we'll divide this into X train, Y train, X test, Y test. That means suppose here X and Y is here in the data frame and here is 100 data points are there. Okay. 80 points from X, that will be X train. 80 points from Y, that will be Y train. Now what is Y train here?
Trend, right, Ashish?
The target
trend.
of the
Why-
sample data that we have trained, like the output of X trains is Y train.
So this Y is also called your ground truth data. Ground truth data means the real fact based on the fact based on the historic data. That means suppose you are classifying this row, this part is X train. Okay. Consider our data set. This part is X train, date, time, then the user device and something like that. And Y will be fraudulent. So if this is my model, I am going to provide the X train and Y train into this model. Any confusion between X train and Y train here? Anyone who doesn't
Yeah,
understand?
I have one doubt. See, like when you're assigning X, see X is the unknown value. Now you're saying X equal to X, and again you're saying X equal to Y. So here the basic logic only I'm unable to understand.
Actually, because of my writing, this is not X, this is Y. Okay, this is X. So X equal to X, what I meant means X is the independent variable. That you understood? Independent variables.
Yeah, that I got.
Y is the dependent variable. Okay. X is, so forget about everything. Now listen, X is the independent variable, Y is the dependent variable. You pass to the model this independent variable along with the dependent variable. Now making sense to the model here, X and Y. To your model training, you are providing X and Y. X is the independent variable, Y is the dependent variable. But here we are not passing all the X or all the Y, only 80. Suppose 80 points I consider as for my training. So 80 points from here, from X, 80 points I will pass to the model. Next 80 points from Y will be passed to the model. So now here X train, Y train, you understood from your example of 80 points, data points.
Yes.
Okay, that means now model will learn. This is called model will learn from this X train and Y train data. And it will, once the model training is done, the rest 20 points you have, that is X test. Okay, I'm not using the writer here, guys. X test and Y test. What is this Y? X test and Y test? The left out part of this 100 data point, that is 20 points.
The outlier.
So similarly for, yeah, sorry.
The outlier.
No, not outlier. 100 rows I have, I use.
Okay, the remaining 20.
The remaining 20. The remaining 20 also will have X and Y. That name I am giving X test and Y test. See, I'll summarize again. 100 rows I have. 80 rows I am giving the name as X train, Y train. Now, what is X, what is Y, you know, right? From this 100 data points.
Right.
80 rows I am saying X train and Y train, and I trained my model. Once my model will train, then I will test this model, the model performance, how the model learned from the previous data. I will test the performance using X test and Y test. How does that? I will test the performance. I will pass the X test to my model, and the model will predict me the new Y test. And I will compare the new Y test and the Y test I have. Please think it properly. So once the training is done, my model is now called a trained model. Now I want to test, I want to verify the model is working properly or not, or what is the accuracy level of this model. So I am going to test this with this test data. So once the model is trained, I will use X test to predict Y test, the new Y test predicted by the model. So
But
Y
while
test,
we were training, while we were training the model, we'll give the dependent variable and independent variable to train the model. Once it got trained, like the 80% of data has been given to the model, then we'll give the independent variable only, which means the X
to
test.
test,
Then we can.
correct,
Okay.
correct. So to test, I will pass this remaining 20 data points. I will only pass the X test, and it will predict the Y test for me.
Okay.
New Y test. Okay. Then, but I have this Y test data previously. This is called ground truth data, right? A Y test I already have. One Y test new is being predicted by my trained model. Now I'll compare the result of the predicted Y test new and the Y test I have. Are you getting? I will compare the predicted value to the value I have here. And I will see for each prediction whether it is similar or whether it is equal to the ground truth Y test or not. In that basis, I will calculate the accuracy or the performance of my model. This is what is happening. So you got an advanced knowledge of machine learning. Hope it will help you in the upcoming sessions. Now, based on this logic, we are going to do this this example of treating the NAND value as a separate class. Let's try to see that how we are doing that. So first of all, I am creating test data and train data. How I'm creating test data and train data? Test data without B column. Can you see? Test data equal to df B column. So this is my data. Let me show you. This is my data and test data. Can you see what is the test data now? What is the test data?
The NaN value containing rows and columns.
See guys, train data and test data, from there also we have to divide it to X and Y, right? X independent variable and dependent variable. That we have not divided. We just created here the test data and train data. Now see what is happening. Train data is those rows, test data is those rows which contain NaN value. Agree? And train data is those rows which contain non-NaN value. So 2 rows in test data, 2 rows in train data. Just to make you understand, I using this small data set, okay? But usually this is not that this much small. So now train data, test data we develop. Okay. Now let's create X train and Y train. Okay. How to create X train? So this is my X train data. Can you see from train data I created this X train? Did you understand? So tell me here, what is my independent variables here? What is my dependent variable here?
A, B, C is the independent and B is going to be the dependent variable, right?
Right, exactly. Great. So this is, that means X train. So if this is my X train, Y train will be my B column. This part. Similarly, what will be X test? Tell me what will be X test from this data frame? From here, the whole data frame, tell me what is X test. X test and Y test.
1, 2, indices 1, 2.
Indices
1, 2, X test equal to indices 1, 2 without B column.
Correct. So X test will be row, second row and third row without the B column. That will be my X test. Are you getting why I created this X test? So that I will predict using the model. The model is going to predict me the Y test. What is Y test here? The NaN values. So here, using the ML concept, this Y test, I am going to get predicted by the model after training. Making sense now what I explained and what we are doing here?
Sir, can you please explain this X test, X train and Y?
Okay, sure. No worries. So I told you X train and Y train, sorry, first let's try to understand test data and train data before going to X train and Y train. Test data, train data, you understood, Liksha?
Yes, sir. So for test data, we have taken the rows having NaN values.
Having NaN values. Why we are
Yes.
taking test data having NaN values? What is the benefit of taking test data as NaN values?
To predict, the
Correct.
model should
So that,
predict the NaN values.
so that the NaN part, the model will predict for us after training with the X train data. Now train data is the rows without having the NaN values. Now with these two train data and test data, we are going to split this into X train, Y train, X test, Y test.
Yeah, okay.
Then tell me in train, what is X train, Y train? Think about it.
X is independent.
Independent. So what in my train data, what I'm considering my independent variable? A column, C column, and D column.
Like how
A
are we
column?
predicting that A, C, and D are independent? Since like we had NaN values in the B column, we are
Correct.
assuming that it is
Exactly.
independent
Correct.
variable. Okay.
Correct. So here my X train will be the columns A, C, and D. That's what I did
Okay.
here. X train A, C, and D. Okay. Now
Okay.
Y train will be the B column.
Yeah, only the B column. Yes.
Only the B column here.
Yes. Yes.
Okay, so this is my Y train. Now let's whatever we understood till now, let's do that. Okay, so this is what I created. This is what I explained in the above code. Okay, I created X train, Y train, I created test data, train data. Okay, now I am creating the model, empty model, using random forest regression library from Sklearn, random forest regression. This is how you are going to create your model. Okay, I'm not going to tell you what is N estimator because those are algorithms and you need to understand. Dedicated sessions are there for you. Just think like there is a parameter called N estimator. Just 1 second, guys. Okay. Now this estimators is a once you understand the algorithm behind random forest, you will understand what is N estimator. Okay. So here I'm just randomly taking 100. So basically in this line, I am creating a untrained model, random forest regression model. And here, this is how you need to do the training. After creating the model using the object, here RF, I'm giving the variable RF dot fit. Fit means you are training or you are fitting the X train and Y train data. So these are what? supervised algorithm, guys. So in supervised algorithm, always remember you have to pass that X train, that is the independent variable, and the dependent variable. Now, once this training is done, this is so simple. See, with 2 lines of code, you created the model and you trained it. Have you imagined that this can happen in machine learning? 2 lines of code, you created the model and you trained the model. And this is same for last set of data also, but there you need to follow certain steps that you are going to encounter in previous upcoming sessions. So here my training is done. Tell me, what is my model here? What is my train, which I need to call is my trained model?
RF.
This one. Now, if you see here, test data, X test I am creating. X test means without the NaN values, those column containing NaN values, that is my X test. And I am doing the prediction. See here, predictions. RF dot predict. See, this much simple it is. Create a model, train the model, and predict the new values. Okay, let me run this code. And this is what the model is predicting, the test data. With the test data, regarding the NaN values, the model is now predicting 5.63 and 6.38. So now you can impute these values with your NaN values. Making sense, right? So this is also one other way to deal with the NaN values. Now it depends on your data that you have, the business knowledge you have, which one you want to follow. Okay, guys, any query here?
So that last part, can you please explain to me? That model you have created, that I understood. RF.fit also I understood. Like the
This
last
one
2 lines
understood?
of code. Yes.
Okay, so here test data I am creating. What is the test data? From this, tell me, this is my total data, which is my test data here, X test and Y test. X test will be, what is my test data? First of all, this is my test data. Agree?
Yes, sir.
What is my X test? That is my independent variable in the test data. That is A, C, and D
A,
column.
C, and D. Yes.
That's what we did there. Okay. So we created the independent variable from the test data, that is X test, here by dropping the B column. That is means we only kept A, C, and D.
Okay. Okay, and we are getting the Y test value.
And that model is now predicting that X test data. What is my Y test here? What is my Y test here?
Y test is the B value of,
Which these 2 NaN values as my Y test.
yeah.
But in real life, you have Y test data, but here you don't have the Y test data, because this is what we are solving, right? The NaN value, we are making the Y test. Okay, so here for NaN value, we are predicting using A, C, and D column from the test data. That is these 2 rows. Tell me how you can impute this data. Think about it. That you can use that field now or replace now, or you can, if you have more number of predictions, then you can use a for loop, create a list or array and iterate over that and impute your missing value. So many ways. Okay, guys, all understood? Any query? Interesting, guys, interesting. So once this course will progress, the more concept you are going to learn, those will be interesting actually. So that's why machine learning actually the basic steps to understand, then you can go for other AI role or deep learning role and other. Machine learning is the basic. It's kind of a ABCD of data science. Okay. Let's go to the next. Yeah.
So there are any other models that we use, like?
There's so many. So in your syllabus, in this courses, you have 6 to 7 types of models you are going to learn. Okay, this is one of them, just one of them.
Okay.
Okay, logistic regression, your support vector machines, decision trees, random forest, boosting algorithms, so many are there. Okay, so you can use any one of them based on, so once you understand the concept behind it on these models, then you will understand which model to use in which case. Okay, I'm not going to that part, that is, extensively we'll discuss in particular sessions. So just you got a small, kind of starter here. Okay, main course is yet to come for you guys. Okay.
Okay, so in
okay.
machine learning, there is a 4 main components with there. That is X-train, Y-train, X-test, Y-test, right?
Correct. Right. So this is what we were. This logic is same in the deep learning also. Every data science related model that you are going to create, this for supervised learning, this concept is there. First, you create some train data, then you create the test data. Train data will be used to train the model, and test data will be used to test the model by comparing the ground truth data with your predicted value. This logic will be same for every model.
Okay, so after this, like we can create a new variable for the data frame, and then with the ease now, like by passing this variable into it, then we can impute it, right?
Correct. So imputation, I think you know how to do it. You can develop your own logic. Suppose you have thousands value to impute, then you can think something which will
for
be
loop
or anything that you can think after that.
Totally.
But the concept.
I have a doubt.
Yeah, please.
Here in this example, we had NaN values in only single column. In practice, we might get in different places in different columns. Then it will be more complicated to separate X and Y values, test and train data, right?
Totally agree.
Then how will we proceed?
Other options you have, right? Apart from this one, which option?
Yes.
So, that's why I told this from which one to choose from these all options depends on the data you have and the domain knowledge that you have, or you can think which one will be better for you. But the point is here that we need to understand all possible options. Maybe this is not all possible options. If we'll try to do on research online, you will get even more number of options to impute missing values.
Okay, then we need to change that random forest that into some other. That's what you're saying, right?
Also, I am saying if you are not going to follow this prediction imputation, you can go for what? That mean imputation or mode imputation, categorical imputation.
Okay, sir.
Not this one. So that depends. Suppose you have multiple NaN values in other columns also. You carry out, because this depends on the column. Here ABCD is the main part here. Suppose in particular one column you have so many NaN values. Not so many NaN values. Suppose 50 NaN values. 50 you have data, 50 you have NaN values. So you use this technique to go for that particular column.
Okay.
And the rest of the column where few values are missing, you can go for a mean imputation, mode imputation, or categorical imputation. Okay, you can combine these techniques to decide which one to go.
Okay, sir.
Okay. No worries. You will good question. Actually, this kind of questions coming means like you are understanding this concept, started understanding. That's a good sign actually. Now let's see encoding the data. What do we mean by encoding the data? In machine learning, encoding refers to the process of converting data into a format that a model can understand. Now always remember our models, not all models, maximum number of models will understand these pictures that we are sending, the text value we are sending, the numbers that we are sending to train the model. Model is not understanding the picture or the text data or the numbers or all. It is understanding some numbers. That's why mathematics is important in data science, because in machine learning, machine understand the number. Suppose in train data, we have the names, the people of from this session, those names are my train data. And I am feeding that to a model. Suppose, for example, I'm saying, now the model is not going to read the names. The model is going to assign one number to each name. Suppose Assis will be 0, then Dinesh will be 1, then Diksha will be 2. Like this, every name it will assign one number. It is not going to understand the text. Because the machine learning algorithm, whether it is random forest regression or logistic regression, all the machine learning algorithms, there is mathematics behind it. And where is mathematics? There is calculation. And where is calculation? You need numbers. Are you getting that differentiation, that multiplication? If I'll only pass the names, how that is going to be performed inside the algorithm? So that's why machine will convert this. Either machine will convert this internally, or we have to encode the data before feeding to the model. Okay. This typically involves converting categorical variables such as strings into numeric values, as many machine learning algorithms require numerical input. Common techniques for encoding the data is one-hot encoding, very popular. You might get questions from this kind of. So to be honest with you, I have encountered so many interviews, and this kind of question is common. Okay, what is one-hot encoding? How you do one-hot encoding? Why we do one-hot encoding? Right. So this kind of questions also we come. So how many encoding we are going to study here? Now this is not all also, guys, because every day new things are getting invented. Okay, so the point is, once you understand this one, you can easily read and understand other encoding techniques. That is the main part here. So one-hot encoding, label encoding, and ordinal encoding. So we have mainly 3 types of categorical data. So when I say categorical data, that means what? Not continuous. Binary, ordinal, and nominal. Binary, ordinal, and nominal. What is binary? 2 categories.
Yeah, 0 or 1.
Yeah, male, female, your yes, no. Like you have 2 categories: fraudulent, non-fraudulent, spam, not spam, spam mail, not spam mail. Right? So these are binary categories. Okay. Now here, let's try to. So suppose I think this is not my data frame. Let me run my data frame, guys. 1 second. This is the data frame that we created to understand. Yeah, so this is my data frame. I hope I have uploaded the file. Yes, I have uploaded the file. Okay, so now this is my data frame. Now, how to find out binary categorical variable and other types of categorical variable from your data? How to do that? Now, how to first find out all the columns? This is what you need to do, right? df.columns will all my column names, right? So we have 21 in our example, right? Now, if you see here, there is a column called agent connection type. Is it binary or non-binary?
It's binary, cellular or Wi-Fi. There is a two
categories. Right?
categories only. Yeah.
So this is an example. This column is an example of binary categorical data. Now, as part of the encoding that we understood, we can't pass this Wi-Fi and cellular to our model. We have to assign a number to it. That is called the encoded value. Okay. Why I have written this head equal to 20? Okay, just to show you. So guys, the NaN values is still there, right? We freshly load the data frame, but you can see here Wi-Fi, cellular. So few of the things it is there, right? Let's see 30. Wi-Fi, cellular. So maximum NaN values are here. But so what type of imputation you need to do here, guys? Tell me. Maximum, so 748. So what type of imputation you can do for the NaN values?
Like we can take out what is the percentage of data having cellular value. So that percentage NaN values we can go with.
Right. Okay, just a quick recap of our previous session. I hope you understood. Now first you impute this NaN value, then cellular and Wi-Fi will be there for every rows for you, right? Now, how to filter out only binary features or binary columns in your data frame? This is the code. Can you please try to understand and let me know if you didn't understand any part of here? This code, this one line.
What is that object? D type is equal to object.
This one, right? This one. This one.
Yes.
So here, if you see, I am using a list comprehension column for column in df.columns. That means this what I wrote here. I am iterating over each column after getting the list of all the columns. This part clear? Okay. Now, after iterating over each column, you are checking that particular column's data type. Did you understand how we are checking the particular column? So we are going column by column and checking the data type present in that particular column, which we are equating to object. Object means what? Text data, right? Not numerical. If it is numerical, can I find any binary features if few of my columns are numerical?
No.
No, right? So that's why we are equating this with only the object type. That means text type. If so, you go one by one to each column and check the data type is text type or not. This is what we are doing in this code. Understood? Along with this condition, along with checking the data type, we are also checking another condition. That is what? The column. You are iterating over each column. In each column, the unique value present. This function will help you find out the unique value. Now, if I will apply the unique value function here, tell me what will be my output? Unique, right? What does this mean? How many categories you have inside that column? For binary features, how many categories we have? 2. Guys, am I making sense?
Yes, 2.
Okay.
Yes.
So that's what, along with this data type, I am checking this condition where the number of unique categories present inside each column equal to 2. And I am just
What is the n in unique? Like unique means you can write unique, right? What is the n here?
no, that is how they define the function in data frame to
Okay.
check the so this is called the number of unique.
Okay.
Number of unique categories. This is not what we are defining. This is by default they have developed inside pandas data frame. Okay.
Okay.
So n unique method, if you will apply, you will get 2 here. Now tell me, this is my binary columns. This is how I extracted the binary columns. So out of my 21 columns, these 3 columns, what? SN connection type, device per user, receiver. These 3 columns containing binary categories in my data set.
So even df.columns can be used to get this, right?
df.columns can be used to
Get this value of columns. You got 2 right now. If you, like, since you have used n unique method, even df column, it gives the same thing, right?
I'm not getting it. What df dot columns?
Like, yes,
Which part you are referring in this code?
like for this df column dot n unique method you have used, right? So
Oh.
it gives the number of columns, right? Basically.
No. Okay. Let me explain again, guys. Okay. So see, column for column in df columns. What does this mean? You tell. Column
For
for
each of
column,
the column, it will iterate.
right? That means
Yeah.
tell me this column will be, tell me one possible values or two possible values in the column. What this variable will contain? Column name or data frame?
Column name.
Column name, right? So this is the column name. Column name means like this, right? Agent type, device of user, like this column name. Now,
Yes.
to find out the data inside the column, what you need to do? How you access the column data? The data frame, then the column name. Like this, you access it, right? Every column.
Yes. Yes.
So this is what we are doing. We are accessing that particular column data, df, then in the bracket, the column name.
Okay, this n unique is applicable to the data present inside that column.
Data frame. This is a data frame. You understand? This is a data frame.
Yeah, so data
Right?
frame has the columns and the data inside it. So here n
Correct.
unique is being applied to the data frame.
Data frame for that particular column here. So see, if I write df, it will give me all the data, right? Like this, right?
Yes.
This is, and suppose if I want to access any particular column, what I need to do? df, then
That column name.
column name. So this is just one column, right?
Yes.
Okay. And here, after doing this is nothing but this one, but iterating over each column. Here I show you one particular column. Here it is iterating over each column through this
Okay.
for loop. Okay.
Okay.
And here, if
Yes.
you, after doing this, we are applying what? N unique. So here emulator is not, guys, emulator column is not, why it is not coming as my binary features? I can see emulator is 2. Did I did some mistakes?
Is it numerical data?
Oh, okay, sorry, yes. Okay, sorry, guys, sorry. So that is numerical data because we are only considering the text data.
Yes.
Excuse me, sir. That we have binary, ordinal, and nominal data. All the values are display as like test only, object type only. How can we different from the binary and binary data, ordinal, and now we are doing for the binary data?
Correct question. So I have not gone to actually ordinal and nominal. We are only at binary one. But yeah, good question you asked. So you tell me, if number of unique categories is 2, that is my binary. But what I need to do the changes here so that it will be my non-binary data or more than 2 types of data?
Actually, I'm getting confused in that unique df of column where we are go to the all the columns in that for loop, and if the data type is object in all the columns, we are and the df of column n unique means in each column that unique value, each column may have the different values.
Yeah.
That n
suppose
unique equal to 2 means.
That means suppose you have 2 categories, male or female in the column. I'm saying each row you have either male or female, either you have fraudulent or non-fraudulent. 2 categories only.
Ashish, can you run without n and then run with n? Unique with unique here on 16th on the 16th tab.
With okay, 16th.
16th one. Can you run with n without n and n? Yeah, then it will be.
number of unique and only unique. Here NaN
Unique will
values
be
will also
NaN.
come.
Okay,
Huh.
okay. N unique means it will be become only two, that either male or female, like what for fraudulent or not fraudulent, checking like.
Correct. So how many categories are there? So basically, N unique will tell you how many categories are present inside that particular column.
Okay. But
And
we may have too many values, right? We in all the columns we can't able to get the two number of categories only.
that's
But
why
other
we're
type
filtering.
of
See, that's why we're filtering out only for two, because what is our aim here? To capture only the binary features, not ordinal and nominal, only binary.
okay. Now I got it.
Yeah,
thank
only
you.
we are capturing the binary one. That's why we are making it to two.
Like zeros and ones, so that we have giving the two. Yeah, okay.
So
Thank you.
these three columns contain object data type with two category in it. How to select multiple categorical features, not binary? What changes I need to do here? Just
N
this.
unique greater
Yeah.
than 2.
Okay, so this means what? All the features having multiple categories. So these are the columns which contains text type of data with multiple categories. Okay, and this is also one code that you can also write to get this. What we did here, this is same thing you are going to get, but here you are using select data types function. Select data types function. In the documentation, you will get more understanding what is. So this means what? Apply the select data types function on my data frame. Include the floating points. Floating points means what? The columns with floating points. Dot columns. Again, you have to write. So this is a bit of complex one rather than this one, but both are achieving same result. Both are achieving same result. Right, guys? You can see. Okay, now this is how you have to capture what? Your specific categorical features or columns. Now what is next? Now how to encode this one? Okay, how to encode this one? Suppose agent connection type we are seeing, right? I think this one we made understand in the previous batch. Okay. Now can you see how I am? So encode means what? Each category you assign a number. That's what we say, right? We have for binary features. If we like give one number, either you give one category as 0, another category is 1. Making sense? So agent type connection, what we have NaN values, Wi-Fi and cellular, right? Two values we have, right? Wi-Fi and cellular. These two categories we have. Now let's give one category as 1, another category as 0. So model will understand 1 means Wi-Fi, 0 means cellular. Not model will understand, model will consider this as a number. But you know 1 means Wi-Fi, 0 means cellular. Now how to encode this? So what I need to do, I need to go to this column, go row by row. Wherever I found Wi-Fi, I will mention 1. Wherever I found cellular, I will make it 0. This is what I am going to do as part of my encoding the binary values. Now, can you see here? Can you try to understand this code? It is simple This, you have seen this dot apply, then the lambda function. Now you tell me whether you are able to understand or not.
Yes, sir.
So that means apply the lambda function. In which direction it is getting applied, guys? In which axis?
Zero.
By default value it is taking. That means to go in the vertical direction. That means go row by row.
X-axis.
Not x-axis. See, this is your data frame. Suppose this column I'm talking about. This column is called SN connection type. Now, how you need to go to check whether it is cellular or Wi-Fi category is there? How you need to go? Like this?
Yes, yes.
So this is which axis? Y-axis. That means
Y-axis.
equal to 0. Axis equal to 0. Okay. So that's why I have not mentioned any axis, because by default it is axis equal to 0, right? If you need to perform this action in horizontal, you have to mention. Where you have to mention? Where I have to mention axis equal to 1? Which part?
At the end,
Last.
Here, right?
yeah.
Here, right? Axis equal to, right? Because this apply function will take that value as axis, right? Now that means apply, go each row, x is my input to the lambda function. Output is what? 1. 1 means what? 1 if you find this input is equal to cellular, equal to cellular. Else you give 0 if x equal to Wi-Fi. If you don't find this 2 also, cellular and Wi-Fi, then you give none. This is what it is. This is telling you, right? And I think we have explained this. I expanded this in the for loop.
Yeah.
Can you verify this for loop is exactly same as we are discussing?
Oh, yes, sir.
Okay. So this is how you are going to do. And this is called encoding the binary features. Now let's do it.
Ashish, like here you have used else in that else again, and if in else you have used, right? So we can also use elif in this situation, right?
But in
So
list comprehension, we can't be able to use else.
correct. Dinesh, I think Divya answered your question.
Okay.
List comprehension, right? Inside list comprehension, that is only else. Nice. Now, have I run this code or not? Let me see. Also, guys, this column contains the NaN values. We have not imputed this one. Okay, like let's try to impute first, then go for this encoding. And I think that's what this is why it is saying NaN value, because like it is getting NaN also, right? Let me get 30. Guys, I think we're getting NaN everywhere. Is it like NaN everywhere? Something is wrong, guys. Silpa, you there? I need your help.
Yes,
You are
Ash.
there, right? Why it is coming as all none here? Did we did any mistakes here?
Can you just see the unique values we have in agent connection type
Unique value, huh?
after this line, after applying lambda function, what is the value?
all none now.
Yes.
Just a minute. Let me run this data again. You only asked this none and that time, right? So I remember your question.
I asked you for the float and integer thing, like 0.0, and then it was 1.
Is it okay? So this is my new data frame. Binary features. Then connection type x equal to 1 if x equal to. Now here it is NAN Wi-Fi cellular, right? DS as in apply lambda x else none. Now it is coming. Maybe some issue was there initially.
Between execution.
Correct, correct. Now you can see, guys, what happened. Let forget the NAND values. Now can you see? Now 0 and 1 is there, right?
But we have assigned the value in integer. Now it is gone to float.
Float, right? So you can do one thing. But this is integer only, right?
Yeah,
What
that
was
is already.
that is something called a D type, right?
Type
Okay.
equal to int 64. You can try that.
It was there, right, Silpa?
This
Previously
was the
saw?
same question I had added, like
Okay, okay. What is that? Integer, right?
yeah, int or int 64. Let's try. I think.
This is a D type equal to this one. Just a minute. I have to then run this code again. For better purpose, what I'll do, I'll copy this to this cell so that I need not to scroll every time. Just a minute. Let me copy this. Here I'm going to paste it again, right? So let's see whether it is integer or not. Data type is not, should not be there. Something unexpected keyword data type. You didn't ask for this one. That was actually for some other like other encoding that we are
Actually, it
doing, right?
was this one only. I remember this. It was an encoding.
Just a minute. Let me see then why we are getting float. Can you try to debug, guys, what we need to make so that it will be a, but we are passing x equal to 1, right? Just a minute. This is integer only, right? Shall we pass like this?
Yeah,
This is integer
but
only.
there the typecasting was unrequired, right? Because like we were giving it as an integer.
Okay, but we can debug it, guys. Okay, so basically let's not do this right now, or it will consume. So suppose you want only 0 and 1s, right? And that, okay, the data type is float 64 here. What I need to do, just a minute. I forgot actually. Apply. To understand this, I think we need to go for df.apply. Give me 1 minute, guys. Let me quickly search. If I find that is fine, or else we'll see. Or you can also try to find in the background, guys, how to make the all the apply things will be in integer documentation. Let's see if I find anything quickly. Functions axis raw. No. Result type. This only after when x equal to 1. Okay. Arguments tuple. Df.apply. Here also it is getting what floating point. Let's try to see result type expand. What is that? No, it is not there. Let me see. Okay, let me see. We have to go through some documentation to understand it. Okay, so do one thing. You guys try to explore. I'll also try to explore.
And
Okay.
excuse me, sir, here we are not converting the NaN value to the somewhat other type that we can't do the model value or a mode median or a mean. Here we are not changing that value. But even though we are encoding the
So first step is to change the NaN values because I'm loading it again and again, so we are not able to change now. So first you change this NaN value. You first impute the NaN values with the method that we discussed yesterday. You first do that, then you do the encoding.
Okay.
This is just to, and I think you asked the same question, but not here. Somewhere here. I forgot actually, but yeah, not here. You asked here like why it is none is not appearing, why NaN is appearing. You remember? Then we saw in Python none is being, NaN is being read in what?
I remember this 0.0 and 1.0.
You remember, but not here. I also remember, but there's something different. Let me check out. See, when I write print this, it is now none.
I'm searching for this one 0.0 and 1.0. Why are we doing that? Like I'm searching in the background. Yeah.
Okay. No worries. Okay, we'll do it. Okay. If we want particularly integer value, not 1.0 or 0.0, there's certainly some method. Okay, don't worry. We'll get that. Now this is how we need to do with what binary features. If I'll recap what we are discussing, we are encoding the binary features to respective numbers. Okay, guys. Now, what is ordinal? What is nominal? Can you understand from this example? Yeah.
So for binary feature, we can use map function, right?
Yes. Map also you can use. So
yeah,
map
that is easy to map.
In map function, what you are going to pass as the argument?
Cellular as a 0 or Wi-Fi as 1.
So for that, you have to understand how map function works, right? What is the argument you pass in map function? Is not there any official documentation in my Python? So what I remember, map function take a function as argument, isn't it?
Yeah.
Right.
You can replace the word as a number, right?
So when you say map, here first parameter you need to pass what?
A function, right? First should be a function and then should be a list or something.
Iterator. Iterator means that list or the column we are speaking, right? So here cellular and this one is not a function, it's just a value. But you can create a custom function which will, do this. You can create a custom function that will take an input of rows and map with this iterator. That's why apply and lambda function is the deadly combination. But you can achieve. Okay, so the ultimate aim is to do what? Binary features, one category is 0, another category is 1. That's what you need to do. You can achieve this thing in different ways, even if in a faster ways also. If you develop your expertise, you can also develop this concept immediately. You can do. You can do the research. But as far as I understand, map function takes a function first to map the function to the iterable. That means that is list or this columns or array. But here we are not mapping any functions. It will use map functions. So to use map functions, first you need to create a function. So the same thing we are doing in Lambda, right? Lambda is the substitute of that only. Without creating a function, you can pass like this. df.map is also there, guys. He is actually right, but I'm not able to recollect right now. df.map is also one function is there. Okay, you can do one research, okay, but you got to know what we are doing, right? You can quickly do the research
Ashish,
here. Yeah.
I'm new to this batch. Can you share that link?
Oh, you are new to
Wha-
this batch.
Yeah, yeah.
So
Collab
those
link.
who are collab link, no,
Yeah.
we are not giving the collab link. So here we have a G drive, okay, and the G drive we are uploading all the nodes in the daily
Okay.
basis.
Okay,
So
okay.
you get this G drive link and you try to access it.
Okay.
Just a minute. Am I the host here? I don't think I'm the host here. Just a minute. Make host. Did I make anyone else? Please save this in your bookmark, then open it. Okay.
Okay, sir.
Great, great.
Thank
I
you.
got some. Okay, you also pinged in the chat. Sorry, I didn't see while. No? Okay, no, it's
Fine, fine, fine.
guys. So I hope you got to know what you can do with the binary features, right? And tell me this one. What do we mean by ordinal and nominal by looking into the example I have given? Making sense to you or not?
Ordinal means we can order the data. Nominal means it's just the words we can see only.
Right. Now, when there is a order associated with it, like or rank associated with, that is called ordinal, right? And nominal means the plain. That, but the purpose is here. This is the tell me the number of unique categories is greater than 2 here.
Yeah, greater than
Okay.
2.
And this is how we are extracting the multiple category columns, right? And these are the columns which contains object or text data type, and more numbers of columns are there. Now what to do with, so suppose this is a very simple step you did for binary. Now tell me one column is there where 100 categories are there. What you are going to do in that case? Or you have to perform this action in like multiple columns. Then what you need to do? Okay, let's see how we can achieve that. The first is, guys.
Ashish, sorry to cut you there. Like the to-do list was there, right? Like a to list. Sorry, the to list will what will that actually do?
To list means whatever your result you are getting after running this code, store that result in a list.
Okay. That result will be like in the multi-category variable will be as a list.
So this is my code. What is this code? I told you the other way
Yeah,
of
yeah.
it, right? The select data types, then the number of unique categories greater than 2. So whatever result you are getting, so suppose I will not give this to list, okay? What will happen?
Even also.
What is the type here?
Underscore base index like that.
Right. So this is not a iterable. We need an iterable. Iterable means what? The list or array or something. So this is what? Although you are getting the result here, but this is not what? A list
The
or
list. Okay.
right.
We
So
can't
to
directly do
make
that.
this,
Okay.
yeah, to make this, what we need to call?
To list.
Label encoding. Label encoding algorithm is quite simple and it considers an order for encoding. Let's take an example of this one. This is a column called event type name in our dataset, which contains 1, 3, 6, 9, more than 10 categories. More than 10 categories you have. Understood? This one you understood? Now let's try to use the ordinal encoder. What is ordinal encoder? That we are going to give some number to this category. That means what? This is one number, this is one number. So that machine will not see these categories. Instead of this, machine will see what? A number. Making sense, right?
Okay, that will be ordered like payment will be 1, session signing will be 2,
Correct, correct,
and so on,
correct.
or it will be in. Okay.
Correct. Right. To do that quickly, you can take the help of Python libraries. Again, machine related modeling things and this type of pre-processing things, encoding things, everything you will get from scikit-learn. Okay, once you complete this course, make this scikit-learn as one of your skill in your portfolio also. Okay, that this will show the recruiters or the people that you have knowledge on model building using scikit-learn. Okay, scikit-learn.preprocessing, you are importing ordinal encoder. From scikit-learn, you are importing ordinal encoder. Now, why I have written this, I don't know. Why I am returning cbon here. Okay, now I am creating one object. Okay, why I did this? Okay, let me first make you understand this one. So here, I think, Silpa, here we are doing that data type, ordinal encoder. Okay, the question you asked, no, it is here actually. You didn't ask there, you asked here. Okay, after doing the encoding, it is, okay. So let's see here, ordinal encoder, and the data type we are passing here as integer. That means after doing the encoding, what I need in a, so if I don't give this, okay, let's not give this, just give like this. So what I'm doing here, I'm creating an object called what? LE, label encoder. Not, this is not label encoder, right? Just a name, right? LE. Now, once you create the object out of it, you just need to call a specific function in here, fit transform. Guys, if you will go to this documentation, you will get lots of information about this. Okay, what is fit transform? What other things are there? Lots of information you can get. Easy. Like the documentation is easy to read and understand, not a complex one. Can you see this fit word previously in this session where we used a fit word? In this session.
Explain Y train.
Correct. Those category we used, we created the model, then we feed the data. Same thing is happening, like same kind of similar kind of logic. Here it is called feed and transform. Feed and transform means pass this data, feed to it, and transform it to the number. But we have to make sure you, after transforming it, you have to save this in that particular column. Okay. Now, if we'll do this, let's do this. Okay. Let's run this. Now, if I run this, if I'll check my new values now, can you see here the categories? Can you see now? The payment and everything is now assigned one number. Can you see? 7, 10. This is 0. Here, Silpa, I think you asked, it is floating point. If I want integers, that's what I need to do. Then I think in ordinal encoder, we have that D type.
Right. Yes. Correct.
Okay, if I'll do int here, now it is integer, right? So guys, did you understand how we are encoding the multiple category data here using ordinal encoder?
And
That
actually,
is
not on the data set. I just use a dictionary of cellular Wi-Fi thing. When I'm using the same apply lambda function, I'm getting 1 0 only. I'm not getting 1.0.
Is it? Then why I am getting float values? Are you sure you are getting the integer value?
Yes, I'm getting integer.
Okay, I think I am getting the float value. I think maybe it depends on the research. We'll see that. I'll tell you tomorrow. Okay, not a problem. Let me do some research. Okay, now here, guys, did you understand the? So here two types of encoding modules functions are there called ordinal encoder and label encoder. Both are kind of same only. You can use any one of them, and you can go to the this is scikit-learn's official documentation, guys. Okay, see, ordinal encoder and label encoder. Extensively, you will get this documentation, and here it is clearly mentioned. Okay, just search. I think here we found the data type, right? Handle unknown. So many things are here. And you can see also there is label encoder, one hot encoder, everything is here also. Reference is here. Okay, guys. So now tell me, this is I did for only one column, right? What if I need to do this for all this multi-category column? Can you think? This is what I did. Suppose you have hundreds of columns like this. You can't fit and transform. You can apply the fit and transform on each and every column one by one. For that, what you need to do? Am I audible?
For loop.
For loop. And I think this is what you need to do. Yes, this code. What? DF multi-category. What is this multi-category coming from? From where it is coming from? This variable. So when I say, guys, when I say DF dot
Greater than 2, what we have that all stored in a multi-category.
so suppose if I'll write like this, what will happen?
It will show the multiple. Yeah.
Only the data frame containing multiple categories. Agree? Same thing we are doing here. DF multi-category. Here what we did, one particular column we gave. Here we are giving multiple columns, right? DF multi-category equal to DF multi-category dot apply. Here we are using apply. What is the function we are giving? Ordinal encoder dot feed transform. If we'll do like this, what will happen? You'll get error. Okay.
सोया
Let me see.
सोया ज्यादा सोप नीचे मत डालना गिरेगा.
So I think the moms are why it is showing me error. Where in which direction we are applying this? Apply ordinal dot feed transform. I think there is some sudden change in this code. It has been
Transform.
expected 2D array got 1D array instead. Just a minute. I think
Is
customer
that after the fit transform, like, don't we need any
access equal to 1, I think we need to give. No.
like after fit transform, there is no need of parentheses, Ashish, like as this
No, not that one.
I think so. Yeah, the LE dot fit transform. If single square bracket and then event type name, because it will.
Sorry, this one, right? This is what you were saying.
No, not this one.
No, it was working actually previously. In your batch also it is working, right, Silpa?
Yes, it's working.
Maybe some recent changes in the code happened. This is also, guys, this is also one, you have to be reshape your data using array.use -1 and 1.
And this multi-category, if we don't give in codes, is it okay?
Yeah, see, this is multi-category. I saw this one, right, by running this in a separately. So this is a data frame, right? Okay. And the data frame, we are applying this, but we are applying the function in y direction. And in y direction,
Ashish, the same code was working in my Google Colab.
This one?
Yeah, the same code was working in mine. Like I'm getting the chart and all those.
No. So this chart I commented out. Okay, this chart I commented out.
Yeah.
Just a minute. Okay, how can like this one be LE? Maybe.
Yeah, you're already ordinal and
maybe LE, right? Maybe let's see. No, let me debug this, guys. Maybe there is some changes in code which is so what does this mean?
LE dot fit transform. Can you just scroll up, Ashish, so that the entire thing is fit transform. Fit transform would be a function. LE dot fit transform.
Yeah, that's why in apply method we are passing the function only, right? I think this is not LE. Okay, two things I need to clarify. Let me. So there is some changes in the code. Let me find out. Maybe there we have to reshape the. What is this? Return transform missing one positional argument. It's something is not working here. Let me. So guys, leave it to me. This multi-category part, how to apply the with simultaneously you can. So what is the aim here? We have to do it simultaneously for multiple columns containing multi-category. Okay, leave it to me. Or what you can do in simple term, you can run a for loop. What is a for loop? If I write the for loop, how should I do it? So here for I in what? Multi-category. Guys, so even if it's for loop also for I in multi-category, then what changes I need to do? df I, okay, equal to le dot
fit transform.
Then df I. This is also you can do, right? Shall we do this and see? Let's comment out this part. Just this one. Hey guys, I think we are doing mistakes in here only, the multi-category. Oh, okay, so this is not the for I in multi-category. This is, I think recently they changed because this type of error was not there in the previous sessions. It is while transforming this error is occurring. Oh, okay. I got it, guys. I got it. I think it is expecting in this format. So I love to debug actually, but
even if you skip the double square bracket in the first place,
maybe
TF of single square bracket I, if you just copy the same thing like you have written for event type name.
which part you are saying?
Yeah,
Yes.
now it's fine. Now it's fine.
Now it's fine.
Now it may. No, still it is.
Okay. This is something different actually. Something they changed in the what is the current version? Let me change it. 1.3 maybe. Okay, leave it to me, guys. Leave it to me. I will tell you two things. What is the two things? One is this data type that is coming as float. Because initially also it is not coming as float, and this one multiple transformation. Maybe so we have to reset it. Let me do some I'll sit some time and I'll fix it. Okay, I'll let you know. But you got the idea, right? What we are doing actually, how we are doing, I'll let you know. But for the single column you got, right? Like this one. Event type in name. It is not working. Okay. No worries. Okay. We'll see. Maybe because. Okay. Let's not post. Okay. No worries. So label encoding you understood, right, guys? Leave this part to me. I will tell you. No worries. But label encoding and ordinal encoding, you got some idea, right? So basically what we are doing, and tell me how this numbering is done here. Why it is 7 now? What is 10? Why 5? What is the random? How this is done?
Because of that value count, like based on ascending to result.
Because if you see here, okay, alphabet A, then A second is to this one.
Okay, so based on
0 means A, 11 means EU, right? So like this it is giving. 149 is the second, that means started with C, right? So this is how it given the number.
Okay, I thought based on the count and all those it was changed like that.
No. The character or the value that we are assigning. Okay. So the idea behind is to do what? Just to change this category to a specific number, so that the model will calculate the numbers, or it will consider the numbers and it will do its calculation. What is one hot encoding? This is interesting. Okay, we have time, right? Yeah, 10:40. Okay, so one hot encoding, what does that mean? So here what we did, suppose this column, suppose this what is the column? Event type. So this is the event type NM column, right? So this is one column where we changed all the category to some numbers, 1, 2, 3, or whatever maybe. What happens in one hot encoding? Now suppose how many categories I have here? Suppose 5. Let's say 5. 5 categories I have in this column. Now if I'll apply label encoding, what we did previously, how many values I'll get here? 5. 5 values means what? 5 numbers. Agree? Now what happens in one hot encoding? You create extra 5 columns. Extra 5 columns. I'm writing category 1, category 2, 3, category 3, like this. Creating how many columns, guys? 5 columns. Understood? I'm creating 5 new columns by giving each category name as one column. Now in the first row, initially, this column contains 5 categories and I created 5 new columns here. Now suppose this value is one of the, suppose what you can say, new, suppose this is, let me give you some extra example. Actually, I'm struggling with my typewriter. Can I guys take 1 minute of yours and get my typewriter? So it is downstairs.
Sure.
It's downstairs. Yeah, just give me 1 minute. I'm coming. I'm coming and getting.
Dinesh, did
Yeah.
you ask for the group thing?
Yeah. For that, like they said that it is against the corporate rule and all those, and then they showed me some kind of a documents stating that like it is against, so don't use it and all those. So like for asking itself, like I think after that I have received 2 or 3 phone calls stating like don't do it. If anything happens, then the warning email has been sent to the whole team, like that.
Okay.
Yeah.
So, the previous thing, like in the evening batch, they all shared the thing actually. So okay.
Yeah, I'm also not sure about it.
What is that you are discussing?
Yeah, the same group thing as just like they said, right? It cannot be done.
Yeah, already we have some few batches already tried to do that, but they are also struggling. So just a minute. I ran to the downside very quickly.
Yeah, we can see that you're breathing heavily.
Just a minute. Just 1 second. I'm ready. Okay. Done. I was really missing my this e-writer. I'd explain this. Okay, great. Nice. Now back. Okay. So if you see here, suppose we are talking about this particular column, right? So here, what is the value? Suppose 5 values we have, right? A, B, C, D, and E. 5 categories, okay? And here we are creating 5 more columns. 3, 4, 5, right? A, B, C, D, E. So this A, B, C, D is the categories of this column. Different 5 categories. Don't get confused, guys, okay? Here, in this column, that is column 4. In this column 4, I have 5 categories, A, B, C, D, E, right? Now I created, using these 5 categories, I created 5.
Excuse me, sir, that A, B, C, D are the row values or the column headings?
A, B, C, D is the categories present inside this column.
Okay.
This 4th column.
Huh.
You have 5 categories, A, B, C, D, E. And using those
like with the 4th column categories, you are expanding the table, or you are expanding the data set into another things. Like for example, they okay.
Correct.
Totally.
Expanding this data set by adding 5 new columns. So these 5 new columns I did for what? 1 column, this column. And now what is one hot encoding? Now suppose in the first row it is A. In the second row I'm talking about this particular column only, right? It is
Yeah.
B, it is C, it is something like this, it is written, right? So here, if it is A, then I am going to write in these 5 columns 1 for A, rest everything is 0. If it is B, then 0 here,
0,
1 in
0,
the
0,
B, then rest is 0. If it is C, then this is 0, 0,
0,
1,
0,
0,
1,
0.
0, 0.
So this is called your one-hot encoding. Because in ordinal encoding or label encoding, there is a order, right? 1, 2, 3, 4 numbers are in order. So there is a chance that the machine will give importance to the first order. Because or there is a chance if you have suppose 50 categories and your last number will be 50, the machine will give more importance to it because it is having a value equal to 50. That is one drawback inside label or that order encoder. Hierarchical structure is being created, right? Suppose you have 50 category, then 50 numbers you are creating till 50 in label encoder, I'm saying. So there is a chance that maybe the model will give, because model will see this is 50. So maybe this is an important category or important part. But that is not the case, right? We are just making this category to a number. We don't want to give one category importance and one category less importance. Are you getting the problem here? Now, this problem we are removing in one-hot encoding. But here is also one problem is there. I'll talk about the problem. But here this hierarchical number assigning thing is not bothering anything, right? Because we are giving 1 to this particular category, rest every category is 0. One category B, for B we are giving 1 and rest everything is 0. So this is called your what? A one-hot encoding. Now tell me what is the drawback by doing this? Not you, Silpa. You know, let others think.
Which one, Ashish?
What can be the drawback if we'll perform this one-hot encoding?
Okay, so in here, like in one-hot encoding, like this is not that like we have to take the last column, right? Like we can take any columns.
We are doing for the
For example, like
column.
what
If
I'm
we have too many columns, for the too many columns, we can't able to do this for every column. It will be time taking or
right. So Divya, you said the right thing here actually. So that is one major drawback here. Suppose consider one column contains 100 categories. That means how many columns you are creating? 100 more columns. And that for only for one single column. Here for this one column, we created 5 new columns, isn't it? Now suppose consider this first column contain 100 categories. So how many other columns you have to do here? 100 columns. So this is called your dimension increased. Dimensionality of your data set is increasing. Are you getting? Dimensionality of your data set is increasing here, which will be a cost associative thing for your work environment, because every time we are increasing the data and the dimensions, we are increasing the resources in our system to occupy that. And the resource management, I told you this also previously, resource management is also a vital thing in real life scenario in the real life companies. If you are writing something which is consuming less resources, then that will be preferred over the other logic that you are writing, which is consuming more resources. So dimensionality reduction is this is machine learning. This is called curse of dimensionality. Curse of dimensionality. This is an interview question also. They will ask you, what do you mean by curse of dimensionality? That means with increasing dimensions. So I told you, right? What is these columns are nothing but what? The dimensions. With increasing number of columns or dimensions, your performance of the model or your performance will be decreased. Because if my data set containing 3 columns, this is a 3-dimensional data. If it is contain 5 columns, this is a 5-dimensional data. And for
You said
each
what is
column,
curse of dimensionality, right?
right. So with increasing numbers of dimension, your performance will decrease, or it is going to occupy more memory, more space, more resources to calculate. Because at the end, what is happening in the model? In the model, if you provide this data, if will provide this multi-dimensional data to your model, what is happening? Some mathematical operation is being performed, right? The more the dimension, the more the mathematical operation is going to be performed. And the more the mathematical operation is going to perform, the more resources is going to occupy or take, isn't it? So this one hot encoding also, let me read out, okay, whether what I discussed, it is there or not. One hot encoding to overcome the disadvantage of label encoding or ordinal encoding, as it is considered some hierarchy in the columns which can be misleading to nominal features present in the data. So to do that, you can use one hot encoding. Now I need not to explain these things that I already explained in the diagram. Or can you please go quickly and see whether anything new you are seeing, what we didn't discuss? And this is the procedure we followed, these two. Splitting of categories into different columns, put 0 for others and 1 as an indicator for the appropriate column. Right? Now let's see. Now I think this is frequency encoding. See guys, this is the code. We are for label encoder, what we are inputting? Label encoder. Here for one hot encoder, same library. Scikit-learn preprocessing one hot encoder. And we are doing the fit and transform to array. But here what we are doing? We are creating the data frame with this encoded value and the columns. Where this columns is, first let's learn me this one. Columns is not defined. This is my columns. Actually, it was already converted, right? We already converted this one. So this is my data frame. Okay, guys, this is my data frame. This is my column names. Sorry.
Yeah, instead of columns, you have mentioned column there. That's the error, I think. That's causing issue.
This is the category name, right? This is the category name. Just a minute. Let me just perform this one and I will see. So can you now try to understand what I did? Tell me what I did.
For every category, we are doing the coding, encoding 0 and 1. If it is present, it will be 1. If it is not, it will be 0.
So that means I created a data frame here. For which column?
For all the columns.
Not for all the columns, for this column.
Oh.
Event type NN. for this one particular column. So I show you this one, right? So 4 columns we have. We are doing this for the 4th column. And we are creating new columns based on the category have in this column.
But here we have 21 columns. I'm just asking, we have 21 columns in this table. But if we do based on the one coder, this one hot encoder means, do we have to create a this for every column?
That's what you need to do. That's what you need to do. That's why you have to be careful while choosing, because it is like if you are going to perform this, I think not all 21 columns are multiple category, right? Only eight columns. Total 8 or 9 columns are multiple category columns out of the 21 columns. Okay, and for 8 columns you have to do like this. Let's not go to that one. Let's you understand what
when it comes to one hot handling, like we need to perform the one hot handling situation
one
for
hot
all
encoding.
the one hot encoding for all the columns which it has a multiple values. Like it is not only for the one column. Like we can choose one column and then we can perform it. Like if I have 10 columns in a multiple values, I have to perform for 10.
Right, correct.
Oh God.
So our objective is here to do what we are doing here, what we are trying to achieve. That you please don't forget. What is our aim here? Why we are doing all these things?
Make the machine.
You are encoding the categories.
What?
The values to the number, or which is called encoded data, right? That's what we are doing here. Either you can take help of label encoder, ordinal encoder, or one hot encoder. Choice is yours. And we are going to see another encoder that is called frequency encoder. But
so
here,
one question: if the
please.
Sir, if we have like the categories like if it is not object type, it is like integer type or something. If I try to apply this one hot encoder, what will it do?
Yes, that is a very fundamental question. That's why I told you, you don't forget what we are doing here and why we are doing here. When you say you have numerical values, right? This is what you said, right? So numerical values are already numbers. We need not to encode that. Why we are doing the encoding? Because the categorical, the text data, the categories we are giving as number.
Okay, but here we have not mentioned that object, the type as object or something, right?
Yes, because we are doing it for only one column. One categorical column, that is event type NM. Out of my 21 columns, I am doing it for one column. I'm not going to other columns. So this is the same question asked by Divya also. So for you guys, for your clarity, don't go to the multiple columns. Just stick to one column, understand it, then we'll apply to the multiple columns. So this explanation is only for one column out of your 21 columns, guys. Okay, I'll come to the multiple columns. Here, right now, you just try to understand how we are doing the one hot encoding for one particular column. It is clear now?
Yes, sir.
Let's not go to the 21 part. I'll come to that part. Okay, you understand for one column. So tell me, for this particular column, I created this data frame. Is it making sense to you? Just for this one column out of my 21 columns, just for event type NM columns, I am creating this data frame. Here, what is the data frame containing? Each column of this data frame is each category of this particular column, one column. Just one column I'm doing. I'm creating another data frame, which contains what? This category. If I tell you for one column, is it making sense now, guys?
So like this data frame has the existing columns and also the added columns.
No, this is just expansion of this one column, this data frame. But good question. We'll come to that part while we'll concatenating with this with our original data frame. this data frame that we are creating. So this data frame is the result of what? Only one column. And we created a data frame out of it. This is separate data frame, not related to our original data frame. In the next step, we will concatenate these two data frame, one our original data frame and the data frame we created right now.
Okay.
Now making sense, right?
Yes, sir.
Okay, so this data frame is what? Expansions, one hot encoding is expansions of one column called event type NM. Now, let me.
Ashish, I think your video was turned on.
Is it?
Yeah, I think so.
Can you? Okay.
Yeah, now it's
Okay.
gone. Now it's gone.
Ashish,
Maybe
if we don't give this data frame encoding columns equals to this, like columns equals to columns, what I was reading was columns we give the parameter when we don't have labeled columns in our data, then we use this particular argument columns equals to give column names to the data. But this encode, which we are forming using fit transform, that data already has my column names.
This line you are saying, huh?
Yeah, this line, this creating data like this gives me output in which the column names are already there or not. Okay.
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 It is creating the rows with 0 and 1 based on the category we have. Now, once this is created, what is happening?
Yeah, got it. We are
creating
giving column names to this data.
So this columns, so this ENC is the data. Now in the data frame, we are giving the column names, right? So this column names I extracted from where?
The original data.
The original data means from the original data at this event type, this particular column. So these are the categories, right? These are the categories that we are creating as column in our data frame, right?
So this one not encoder will basically do change these things into zeros and ones.
Right, correct. But you need to explain this how it is happening, right? I explained you this, drawing that. So this is not done yet. This is the data frame you created for one column. Then you have to merge this data frame or concatenate this data frame to your original data frame. Like this. See guys, so this is your final code. This is your final code where you are importing one hot encoder, then creating object out of it, then doing the feed and transform of what? This column, event type NF. Now you are creating the encoded column, this one you are creating. Now you are concatenating with your original data frame along with this data frame in the horizontal direction. Okay, and once you do that, you drop this column which, so this encoded column data frame is the result of this column in my original data frame, agree? So once we have encoded this particular column by creating multiple columns, I don't need this data because this contains what? Text data or non-encoded data, right? So that's why we need to drop it. So that means this column created new columns in my data set and I dropped this. I'm not deleting right now, but you can do like this. What? After concatenating, you drop this event type NM. Okay, guys, do you understand what is happening here in one hot encoding? Now let's see after doing this. Let me see you. Okay. And this is how I accessed my data frames first 10 rows and last 15 column. Now, can you tell me what is my data frame shape now? After doing this, what is my data frame shape? 35 columns. Initially, it was what? 21. How many more columns we generated? 14. 14 categories we have for event time NM column. So we generated 14 more columns now. That's why my new data frame shape is what? So that's why the dimensionality is getting increased, isn't it? Suppose you have 100 categories in one column, it will be plus 100. So this is how I access the last 15 columns. You guys understood this part? I location. This is first 10 rows and last 15 columns of my original data frame. Okay, so these 15 is what? Now these are the categories, and whenever there is a category, that is 1, rest everything is 0. And this also is another problem is here. It creates sparsity. What is sparsity? What do you mean by sparse data? What is the literal meaning of sparse word? So guys, I'm not going to continue after this because it's 11, already over 11. So just one more thing is there, that is called frequency encoding, that I'll cover tomorrow. I don't think tomorrow, right? Monday.
Yes, Ashish.
Okay,
Hello, Ashish, sir.
Yes, please.
Good morning, sir. This is Navid from GUI.
Okay, yeah, Navid. Yeah.
So I have certain announcement to make, sir.
Yeah, okay, please go ahead. Yeah, please.
So learners, actually, yesterday we saw the recordings of the DSM-4 class, okay? We found that certain learners were speaking about creating the WhatsApp groups and etc. Even the mentor came into intervention also. Guys, please make a note that you are not allowed to create any sort of WhatsApp groups or LinkedIn groups or Instagram groups. It is strictly prohibited. Please kindly do not indulge in those activities. If you are getting indulged in those activities, you will be terminated for sure. The only point of contact is GUI officials. There is no necessity to create any kind of a WhatsApp groups. No WhatsApp groups have to be created with or without mentor. I hope it's clear, guys.
Okay, then the only thing that group is not needed, but after the sessions or after the teaching process is finished, what we have to do, whether we have to do the project alone or the mentor will help with us through the daily 2 hours we have the class, like the way they will teach to how to do the projects and all those things, or do we have to do it alone?
No. See, for that purposes, you need to raise a query in Zen portal. First point, raise a query in Zen portal, and then the internal mentor team will directly get in touch with you, connect with you via Google Meet, and then help you in doing the project.
Okay.
Sure. So you can continue, sir.
Yeah, sure, definitely. Thanks for this one. Okay, yes, okay, guys. So I hope you got the idea now, right? With this one.
Yeah.
Tell me you understood this, how we are accessing the last 15 columns here? My question was sparse data, right? So sparse data means what? So sparse means what actually? In literally it is a kind of thin, right? Or you can say, so sparsity means your data is containing more number of zeros rather than other values. That is one definition you can say about sparsity. So here, by doing this, are not we creating sparse data? Because you can see here, most of the columns are containing 0 only. Only one column is containing one value, right? So this is also one drawback, that you are creating sparse data. I'll come to the frequency encoding tomorrow. Frequency encoding, I like it most because, yeah.
Is this okay? I just want to know the overall idea of that. We are encoding the data into zeros and ones. After that, with that zeros and ones, what we are going to do?
Yeah, so that is that. So as I said, your like machine learning sessions are still to be covered. So once this you need once this is done, you are ready with your model, right? You are ready with your data. You split train and test, and you train the model.
Okay, train the model means last time what we have seen that example, we have 80 numbers that we have trained that models, and that we are performing the test for that. For this purpose, we are doing this, right?
Correct, correct. So instead of passing add pay or card pin change value to the model, first you are encoding this into a number, then you are feeding to your model. Okay, but in frequency encoding, it is not going to happen. You are not going to create other columns. Instead of that, actually, frequency encoding is the overcome of the problems we are facing in what? Label encoding and one-hot encoding. Okay, here each will calculate the frequency of each category in the column, and according to that frequency, we'll put inside the column. No need to create other new columns. So instead of add pay category, I will mention the proportion or the frequency it is present among other categories. Are you getting what I'm saying here? So we have 14 categories, right? How many, what is the percentage of add pay? Suppose 0.33 among the 14 categories. So instead of add pay, I will mention 0.33. It's a number. So we encoding it with a value, right? So this we'll see tomorrow, guys. Okay. I'll try to debug, not tomorrow, I think Monday. And I think we have to complete till 30th module. Then I think a new mentor will be assigned. I'm not sure. I have to discuss with the coordinators. But I'm not sure how much far we are from 30th module. Guys, are you checking the progress? Let's stop. In which module we are currently now? It's not opening for me. I'm not sure what is happening.
Okay,
Is it actually specific to my system?
No, it's working for me and all. Handling missing data techniques. Encoding data. We were at module 2
data.
session. Yeah. Module 12 session 23. You want me to share my screen to you?
Yeah, if you can share, then people will see.
Yeah.
And I'm not sure some specific issue to my system. I'm not able to load this one. I also bothered the coordinators about it also. But right now I'm seeing that it is only specific to my system. Okay, so module 12, right? So we have to continue till module 13, guys. Okay. Then I think the machine learning part, maybe a new mentor will take. This cross platform or cross learning is actually beneficial for you guys. Okay, don't take it in this way, but if someone else will teach you the ML, then it will make more sense. But I'm not able to see. Yes, encoding the data, right? Module 12, session 23. Then so I think we are session 23 last part, right? And session 24 will see the outlier detection and meaningful data transformation. Then module 13, we'll see. Module 13, from module 13, I also need to take, or someone else will take. I'll discuss with them. Okay, so Monday, we'll go for session 24. Okay, great. So I'll have uploaded the data as well. Any questions, guys? We'll wind up.
Sir, my dash issue, I have shared the emails and today morning only I was able to share. Yesterday I couldn't do it.
Today morning, I was keep checking since yesterday, but I didn't.
I know, sir, I left to office and I had.
Okay. So this morning only you said, is it?
Yes, today morning I sent it.
Okay. So I was waiting for your mail. but okay, if you send today, then let me give me some time. Okay.
Sure, sure. No problem, sir.
If possible, I will mail. I will reply through that mail. Okay, if I'll find the
Yeah,
resolution.
sure. Okay, sir. No problem. Yeah. Thank you.
Thank you, guys. Thank you. Have a nice weekend. Yeah.
Yeah, you too, Ashish. And Ashish, I've gone for a clarification to the coordinator, and it turned like, okay, someone was indulging in instead of a meeting, and all those things were happened. So apologies for that.
No,
I've
not a
gone
problem.
and asked him. Yeah.
See, guys, don't think this as a okay, this should not happen. We should have created a group. That is fine. You have lots of community to explore, right? So not a problem.
No. Like yesterday, I've asked the same thing was happened. Like when I was in a meeting, I've received phone calls continuously, and then asking about do you guys having any conversation and all this. I was saying no, I'm not having any conversation and all those.
Let's not do then if they are not happy. Maybe something happened which they are not sharing, but yeah, making sense. We need to support the platform because it's a good
That I
platform.
can totally understand. Like, okay, when it comes to the organization, like we all have to comply. Like it's also a kind of institution, right? So that we have to be more sensible. So like yesterday also these things were happening. Like I was literally got scared. Like what's happening? Like I wasn't created any groups, and like I'm receiving this much phone calls like that.
Okay. No, that is
Yeah,
good. No, you took the charge on behalf of whole class. So that's why you are getting most of the calls, right? So not a problem.
I think
Let's not
2
do
or
that.
3 calls I have received about this, and then I said I haven't created any groups. Like if you guys want, I'm sure that I haven't created any groups. Like you guys also know that there is no source that we can get these numbers and all those. So let me also say this in the meeting, and we'll just drop these things and all those. Like now they were in the instead of a meeting they've indulged in
No worries,
things
no
that
worries.
happen.
Not a problem for not. We should not consider this as a problem.
Yeah.
So, but yeah, that is fine. Let's stick to the rules.
Yeah. Thank you.
Okay, guys. Okay. See you
Yeah.
on
Bye bye.
Monday then.
Yeah.
Thank you, guys. Bye.
Thank you. Bye.